Okay, so 3.1 is reflections. And I want to talk about, first, before we start this, I want to talk about types of transformations. So there are 4 types of transformations. You have translations, it's an R, and you have reflections, you have rotations, and you have dilations. Now, the first 3 are what we call rigid motion. And we'll talk about that right down below. But rigid motion is exactly what it sounds like. They don't change size or shape. Does not change size or shape. Now, translation is a slide across the graph. A reflection is a flip. You're flipping it over a line. Rotation is a turn. You're turning the graph around. And a dilation gets bigger or smaller, which is why it's not rigid motion. So a rigid motion is a transformation that preserves length and angle measure. Is this transformation a rigid motion? Well, no. Because the corresponding side lengths are not congruent. That's easy to see. So now is A rigid motion? Well, yeah, it looks like it. And technically you can't tell unless you measured it, but we're going to go with that. And B, of course, is not. All right, so page 2. A reflection is a transformation that reflects each point in the preimage across a line of reflection. A reflection has these properties. If point A is on the line, then the point and its image are the same point. If B is not on the line, then M is the perpendicular bisector of BB prime. All right, so first off, let's talk about a couple of things here. So our first image, the pre-image, we see is written as ABC. The second image, after we reflect it, we call it the image, and we write these points as A prime, B prime, and C prime. And you can kind of see that here. And that stands for reflected across line M, triangle ABC equals triangle A prime, B prime, C prime. The reflection, and that's how it can be written. A reflection is a rigid motion, so length and angle measure are preserved. Now the other part of this that I want to talk about is this part. Perpendicular, line M is the perpendicular bisector of BB prime. So if we're talking about this being the line of reflection, okay, the points are equal distance away. So A is on it, it stays on it. B, I'm going to reflect across this line and put it over here. So it said line M is the perpendicular. They're perpendicular to each other. And B prime is the same distance away from the line of reflection that B is. And that goes for C prime, right? Line M is the perpendicular bisector of line segment CC prime. Okay, so how can you reflect a triangle across? Well, here's my line of reflection, line L. So H, I would find out how far away this is, and I would need it to be the same over here. And that's where my H prime would go, and it would be perpendicular. So remember, this line of reflection is the perpendicular bisector of the segments that are drawn between the pre-image and the image. Okay? All right, so what is the reflection of LMN across line N? And we're just going to estimate it. So this would be perpendicular, and this side would equal this side, and that's my point M. Line L, I would draw a line that was perpendicular to the line of reflection, and this side would equal this side, and that's my L prime. I forgot my prime on M. And then N, same thing. And there's my N prime. So my figure would be like that. All right, so let's do some of these. I'm going to turn off the recording while I plot this first quadrilateral. Okay, so I plotted that, and we are going to, oh, and I didn't label it. I should have. This is F, G, H, and J. Very important to label your figures, and then label them with the prime too. And it says we are going to reflect this across the x-axis. So here's the x-axis. So this is pretty easy when it's the x or y-axis because they just got to be the same distance away. Well, J stays on here. Same distance away is 0. F is 1, 2, 3. So 1, 2, 3. G is 1, 2, 3, 4 away. So I'm going 1, 2, 3, 4 away. H is 2 away, 1, 2, and so H prime is also 2 away. And it should look like if I folded the paper on that line of reflection, those shapes should lay right on top of each other. So 0, 3 became 0, negative 3. 2, 4 became 2, negative 4. 4, 2 became 4, negative 2. And negative 2, 0 stayed negative 2, 0. So it also asks what a general rule for reflecting a point across the x-axis is. Well, if I look at it, all my xy's change to x opposite y. And I'm calling that opposite y instead of negative y. And the way you can also write this is reflect across the x-axis, a reflection across the x-axis with a point xy equals x opposite y. Because a negative becomes a positive becomes a negative. All right, so I think that we will go ahead and do this one in the video. I'm gonna go ahead and write those points again. Go ahead and draw my shape. And if you notice, I wrote out my points off to the side too. Now this is a reflection across the y-axis, okay? So here's my y-axis. So every point has to be the same distance on the other side. So J is 2 away from it, so J prime will be over here, 2 away from it. H is 4 away, so H prime would be 4 away on this side. F is on it, so F prime's going to stay there. And G is 2 away, so G prime would be there. And there's my reflection across the y-axis. So 0, 3 stayed there. 2, 4 became negative 2, 4. 4, 2 became negative 4, 2. And 2, 0, negative 2, 0 became positive 2, 0. This bottom one was J, H, 2, 4 was G, and 0, 3 was F. That kind of helps. So my rule would be a reflection across the y-axis of xy goes to opposite xy. Now we're going to do these in class together. I forgot to put graphs on those, so I'll give you graph paper in class tomorrow. This is just restating those rules. Across the x-axis becomes x opposite y, and across the y-axis becomes opposite x, y. All right, so now we are going to describe a reflection across the x-axis. And I'm going to do this one, and then we're going to do the rest of them in class. So it says write the coordinates of the pre-image and the image. We got those. Find the midpoints of the segments connecting two pairs of corresponding points. So they're going to find KK prime, the midpoint, and they're going to find MM prime. And it doesn't matter which 2 points you pick. So midpoint is add the x's, divide by 2, and add the y's, and divide by 2. So I get 1, 1. And then the midpoint of M prime would be negative 5 plus 1 divided by 2, and 1 plus negative 5 divided by 2, which gives me negative 2, negative 2. All right, so now we want the equation. And you can look on a graph and see that the y-intercept is 0, and the slope, you could count slope. Well, we're going to go ahead and act like we don't have a graph there. So our first step would be to find slope between the midpoints. Slope, you got to be careful, is the small m. These up here, midpoint was the capital M. And slope is y minus y over x minus x. So I get 3 over 3, which is 1. Now, this is right back to the 2.4 lesson. Now we're going to find b. So I have y equals 1x plus b. Now, for b, you can pick either point. I'm going to pick this one because 1's easy to plug in. So I'm going to say 1 equals 1 times 1. This is your slope 1. And then I get 0 equals b, which is what the graph shows. So my equation of a line of reflection is y equals 1x plus 0. And we could write that as y equals x. All right, like I said, we're going to do 4 in class. And we can do 5 in class. So I guess we are done.